Alright, this is episode number 19 in our video series Noob to ASM Coder. You're getting pretty close to the end now. We're at the final expert level thread. Really not too much to go over. We're just going to explain C0 code types and how you could use them to make various cheat codes and whatnot. You're essentially getting to the point now where you don't really need the video series. I'll still make the rest of the videos obviously, but you're getting more intelligent enough with your ASM knowledge where you can just read threads and understand exactly what I'm talking about instead of having to watch a video and get told everything step by step. So C0 code types, you might have seen these before. So we know what insert ASM codes are. The code handler at the specific static memory address designated by the cheat code. It will branch off to a designated portion early in static memory, execute the source instructions, and branch back where you left from, continuing on. C0 codes are a little different. They're called execute ASM codes. Execute meaning they are always executing every frame. So as you guys may know, when you apply the Gecko code handler, this doesn't really apply to Dolphin, but for like Wii console, you can change hook type, like on different app settings like USB loaders and disk loaders. Well, this is where you tell the where the code handler is going to be hooked at, essentially. And because of that, these C0 codes get executed every time that hook type is executed by the game. So for example, you select VBI in your settings for hook type. Well, there's actually a function in every Wii game that's called VBI, and the code, whenever your execute ASM code gets executed, is when the VBI function of the Wii game gets executed, which is every frame 60 times a second. So let's go over some basic format, okay? We'll just look at it right here, then I'll copy paste it in the text editor. It's all zeros. Obviously, you don't need an address because the address is auto-determined by the code handler depending on what hook type you select. So it's just C all zeros, okay? And then we have this YY. This byte here is the same deal as compiled C2 codes, designates how many lines of compiled code are below the amount in hex. And then the XX stuff is just your ASM contents. The ZZ values will vary. So essentially, the reason how these C0 codes work is you have the code handler, and it creates a branch to link register and relink instruction. Okay, kind of like we talked about in a previous episode when you call a function, relink it. So what the code handler does is it puts your execute ASM code in its own little function that it calls. So it calls it with a branch to link register and relink. Thus, when you end the C0 code, you need to end in a branch to link register to end the function, if that makes any sense. Thus, because of this rule, all your compiled C0 codes, execute ASM codes, will end with the compiled word instruction of a branch to link register, BLR, then a final word of zeros, or it ends with your last ASM source instruction, then a compiled word of the BLR instruction, just a FYI. And compiling these will vary between the Python compiler and the WeRD GUI. Okay, so let's just, before we talk about compiling it, let's go over register safety. 99.9% of all apps in Dolphin and everything use a version of the code handler from the old Gecko OS 1.9.1.3, meaning it follows this register safety protocol. Okay, oh, and one more thing before we continue, just so if you couldn't see it, I'll blow this up. This is what C0 codes generally look like. As you can see, there's the Z values I talked about earlier, your ASM contents, C all zeros for the compiled execute ASM, and how many lines of compiled code below, just so we get that out of the way. Okay, so register safety. I have in the thread, obviously in green, you can visit the thread and view which registers are safe to use. Okay, and we got things like part of the condition register, condition fields, CTR, certain floating points. Obviously, common sense dictates that the link register is not safe because you ended a branch to link register instruction, right? You would have to back up the link register in some way, shape, or form. Another thing too is with register safety, if you need to use more registers, push and pop the stack. In the previous episode, we talked about calling functions. So go back to the previous episode, episode 18, and I showed you the instructions that you use to back up R3 through R31. You can use that same push/pop the stack method, okay, to back these all up. The only thing is you got to remember to move the link register to like R12 or R11 before you push the stack. R0 doesn't matter because it doesn't need to be backed up, neither does the CTR. Just so you understand that after you just watched episode 18. So we cover register safety protocol. And one thing we'll also talk about is, we'll blow this up on the text editor. Let's say you have some ASM content, some instructions, some ASM instructions here, blah blah blah. Now remember, this instruction right here, C0 codes must always end in a branch to link register, okay? Now, if you want a C0 code to execute once, like let's say you can make your code region free, you just want to be executed basically the moment the game gets booted. You don't want to try to find a static memory address and port it and whatnot. So you decide to use the execute ASM code. To make it execute once, you include these instructions. RX would be in any of the safe registers we talked about, so it could be something like R12, like this. And because of the way the Gecko code handler is and what it uses R15 for, when you overwrite R15 with this branch to link register compiled word, notice how this is the compiled word for a BLR instruction, it'll make the C0 execute only once, and that's it. So that could be useful for you if you need it. Okay, so to demonstrate how the C0 code works, we're going to create a basic source for an execute ASM code just to show it executes every frame. We're just going to make it have a number, load it from the exception vector area, which will be 0 because unused memory, and we'll increment it up and then make it reset, and you can see this cycle live in memory. So we know already what registers we can use. Let's just load, we'll pick a spot. This spot will work in the exception vector. What do we need? Let's do this. We increment it by 1 every time. And we'll make a reset. We'll make it reset after, we'll do 50 in hex, a little bit more than a per second per se. Branch if less than, don't reset. So you could use this as creating like a really jerry-rigged randomizer, even though it's not really random, but because it's executing every frame, and when your other ASM code that you're using this for to load a randomizer digit of some sort, when it does get executed, this is already so random per se that you could like make like a random item code out of this, or like a random track code out of this sort of thing. Okay, so we want to reset once it exceeds 50. And some things to note. Now, the great thing about the Python compiler is that we have the C0 option. And look what happens when we do this. The address gets blanked out. And we don't need, with the Python compiler, we don't have to include the BLR at the end because it does it for us. As you can see in the compiled code to the right, I'll just paste it right here. Like this. There's our compiled code. Now let's just say, for sake of argument, well, I'll just put an extra instruction here. We'll just load 0 into R0. And notice we'll put that back here just so you can view it. So with C0 codes, they're not like insert ASM codes where you absolutely have to have a final word of zeros. Notice how the Python compiler compiles this with the compiled BLR instruction at the very last word. This is normal. The Gecko code handler knows how to handle this. Okay, now with the WeRDGUI, we can get that really quick. It's a little different. You gotta do some manual work per se, because there's no C0 option in the WeRD. Let it load and give me a sip of water. Okay. Grab the source from the other compiler, but let's just get this out here. Okay, CCC. Okay, Control V. Hopefully you can see that. You might have to zoom in. Okay, so with the WeRDGUI, leave the address as this. Okay, you have to put a BLR at the end for WeRD, and then you compile it. Now this one compiles fine based on the amount of instructions we have. Now you see it compiles it as a C2. Remember to put it to a C0. Now let's say we had an extra instruction like I showed you earlier by just adding this load immediate R0 at 0. Excuse me. And obviously we have to put the BLR at the end. When we compile it, look what happens. We get this NOP at the end. So if you get this with your C0 code when you're compiling, here's what you need to do. First, take your C2, change it to a Z0. Subtract 1 from this byte value in the top right, designating amount of lines of compiled code underneath, and just erase the final line. Like that, and you have your C0 code. Obviously it depends on how many instructions you have in the source. So if you end up having that NOP at the end with the WeRD, that's what you can do to get the C0 code as optimized as possible when it's compiled. Obviously with the Python compiler, you're already good to go. Okay, so let's go back to the Python compiler. Compile it. Now where's Dolphin at? As I said, this is region free, so this will work for all versions of MKWe. Let's just go here, add new code, copy, let's call it C0. There we go. Save, close, make sure we have Dolphin memory engine up. There we go. Now we're going to launch the game. Okay, where's Dolphin memory engine so I can hook? Now let's go to our place right here. Okay, one thing I forgot to do, we'll fix our source really quick. As you can see, I did a little mess up. Forgot to store the byte back. Silly me. So take this as a lesson not to rush writing ASM. Compile. There we go. Too lazy to redo this video. But there you go. Just a little lesson what happens when you rush writing some ASM. As usual, always take your time. We'll force stop. I wish force stop was a default thing in this version I'm using. We'll edit the code. There we go. Put it back. Double check it. Close. Launch. Hook. And there you go. Sorry about that. And as you can see, what's it doing is the moment the number gets read as greater than 50, it gets reset to 0 and gets stored back. So this is demonstrating that one, you can make region-free codes out of this, and two, these codes execute every frame, or every time the hook type that you set for Ocarina or whatnot gets executed. I don't know what hook type Dolphin is using, if that is applicable for Dolphin, if that makes any sense. No idea. But there you go. If you're working with something like on the Wii console and you're working with hardware registers, not only will your code be region free, it'll work in any Wii game. So that's another big plus about these C0 codes. So there you go. A little incrementer you can use. Just make sure you include the store byte, which I forgot by mistake. Something like that you can use. Really easy to make. As you can see, it works perfect. Alright guys, that's just a little tutorial on C0 code types. You are completely done with expert level threads. We can now move on to the pro level, the final tier.